Hi, my name is Connie Francis Zarafa. I'm one of the lecturers at the chemistry department of the junior college. One of the things that I do love being a chemistry lecturer is that I get to do some really fun experiments. And of course, as I said, I get to not just teach chemistry, but also, as I said, try the experiments that I like. One of the experiments that I do like, or kind of what I like to play with, is with dry ice. Now, before we basically say dry ice, you mean ice which you dried it with a hair dryer? No, not really. Dry ice is basically solid carbon dioxide, and I'm going to pull it out. So let me try, and I'm pulling it out with tweezers because it's really, really cold. Okay, it basically is at minus 78 degrees Celsius. Now I'm going to throw it into the water, and look at this. This is absolutely wonderful. Okay, it looks like one of those Harry Potter films. Okay, now basically over here, dry ice, okay, is a solid. All right, but at room temperature it changes to a gas. Okay, it undergoes sublimation. Now, over here, what's happening is when I threw the dry ice in the water, okay, basically, as I said, it's forming carbon dioxide gas, but since it's very, very cold, all right, it condenses the water, all right, in air, and that's why you see basically this cloud. Yes, sir. It's the same sort of principle that happens, for example, in real life, okay, when for example, the temperature drops, okay, and it's humid, and we see fog, okay. One of the nice things that I like to see, and as I said, it's very dramatic, and actually, as I said, it's used, okay, in theaters or even, as I said, on films to create that smoke effect. So, as we said, solid carbon dioxide sublimes. This doesn't happen when we have normal ice, yes, if you can say the normal ice that we have. Basically, with normal ice, okay, it just melts. Okay, so I'm just going to move my lovely Harry Potter experiment over there. All right, and basically what we can see is that normal ice melts. Well, why is that? Well, basically, it will melt at 0 degrees Celsius. Okay, it changes from solid to a liquid. Okay, if we want to speak more in complex terms, okay, the molecules in solid ice are held by hydrogen bonds. Okay, and they hold the molecules very, very tightly together. Okay, when it melts, okay, these bonds, all right, the hydrogen bonds, all right, are broken, some of them, all right, and allow the molecules to move a bit. They still are some are still tied with the hydrogen bonds, but as I said, they're away from being in a solid form where they're arranged in an organized fashion. Okay, and they melt, and as we can see, it melts. It melts basically at 0 degrees Celsius. Now, as I was telling you, in the case of dry ice, which I'm going to just put over here, let me just wipe down, okay, because all good chemists need to be kind of clean, all right? So basically, if I do the same thing with my dry ice, okay, we're going to see that's not going to melt. So let's grab a piece. I'm going to get a nice piece. Oh, I love this piece, okay? And what we notice is so we can wait over here and watch it. And basically, in this case, we're going to notice that it's not going to form a puddle. Okay, you're just going to see, all right, you may see a little bit of fumes, but basically, it's going to change straight away to the gaseous phase. Now, why is that? Well, in this case, all right, at room temperature, okay, the bonds which are holding the carbon dioxide molecules together, all right, all break simultaneously at room temperature. So we don't, for example, transition from the solid, liquid, and gas. Straight away, we go to the gas, okay? So over here, as I said, bit by bit, okay, you may be seeing a little bit of smoke, but on the whole, we're not going to see a puddle. Straight away, it will change to the gaseous form, all right? So that's why I really love playing, more with dry ice than actual ice, okay? Because if I do want to feel, like one of those wizards of Harry Potter that we all love, that's what I do. So before I go, let me make a little brew for you, and hopefully, we'll be able, as I said, to entice you to come to the chemistry department. Have a wonderful day, and cheers to you. Bye-bye.